Hi guys, welcome back to Data Every Day. Today we'll be looking at a data set of African economies, or economic data, and we'll be trying to predict if they have a banking crisis given a bunch of other factors. Alright, now I don't want to spend too much time looking at this here, but let's just take a quick look. I notice we may have some duplicate columns. This is a country code. This is the name of the country. And they seem to be unique to each country. And then additionally, this number denotes the country as well. So these three columns are saying the same thing. And then we have some possible, here I'll show you at the end, we have a crisis or no crisis. This will be our target. But we have other crises. Currency crisis, inflation crisis, and systemic crisis. So just want to make sure that those aren't actually the same thing as banking crisis. Alright, let's get started. So our task for today, crisis prediction in African economies, given data about financial climates in various African countries throughout the years. Let's try to predict whether a banking crisis occurred or not in a given year in a given country. Alright, so I'll import the standard stuff, numpy, pandas, matplotlib, .pyplot, and plotly express for easy graphing. You know, I'm probably actually not even going to use pyplot today. That's a pretty simple data set. And then for pre-processing, we'll have the label encoder, a standard scalar, and train test split function from sklearn. And for our models, we'll be using TensorFlow. Okay, so let's get started. We'll load in our data with pandas readCSV function. So pd.readCSV. CAV. Okay, and we'll get that guy over here. African crises.csv. Load that in and check it out. And I forgot to import. Okay. We're checking that out. Let's give it 1 second. Alright, so like I was saying before, it looks like we have these three duplicate columns. We'll only use the case column because it's already encoded nicely for us. But actually, you might want to one-hot it. So for one-hotting, we may just use the CC3 column because it's nice and compact. Or we could use country, but yeah, I think we'll one-hot the countries. Everything else, though, looks like it's in numerical form. So let's start pre-processing. And what's interesting to me is that this one, systemic crisis. It seems like just from this limited data that we're seeing here, a 1 and a crisis often go together. I mean, I'm only seeing 2 occasions, but why don't we check, are they the same column? So we can say dataset banking crisis, that's our target column at the end, equals crisis. That will give us the true and false values, right? And if we cast that as type integer, that will just convert it to 1s and 0s. And if we compare that to the data in systemic crisis, which is already in 1s and 0s, you see it'll be true for many of the values. Now I say many of the values, we can check if any of them are the same using the .any, which obviously is true as we saw. But if we want to check if all of them are the same, we can use .all method. So let's check that, and it's false. So that means these columns are not actually the same. Even though they may be similar in many cases, there are differences, and we should include systemic crisis as a feature in predicting banking crisis. Alright, I guess then the only thing left to do is one-hot the country and label encode the banking crisis. So let's do that. Here, I will just include this in the markdown, what we were doing. Alright, now encoding. And actually, right before we encode, let's check for missing values. So data.isNA.sum. There is no missing values in the whole data set. Okay. And then we'll use CC3 as our one-hot column. Yeah. So before I do that, I'm going to drop the other ones. So case and country are getting dropped. Data equals data.drop case country. Axis equals 1. Alright. Now we look at data, it looks like this. We're going to take CC3 and one-hot it. So if you know get dummies, if we take the CC3 column, that will return the one-hot version of it, where the values for a given example have now been converted into ones in the column of the old value. Alright, so what we're going to do is take this, append it onto the end, and then drop the original column. So let's call this CC3 dummies. And then we can say data equals pd.concat for concatenate the original data and CC3 dummies. And make sure we specify the first axis, so that we're putting them side by side instead of like this, right? Then we drop the original one. Data equals data.drop CC3 axis 1. Okay. Now take a look at data again. We now no longer have CC3 at the beginning, but we have all these one-hot columns at the end. And now we are ready to split our y off of the rest. So y is going to be, what was it called? Looking up here, banking crisis. So banking crisis. Oh wait, sorry. It should be data sub banking crisis. And x is going to be data.drop banking crisis. So everything except the target column. First axis. Alright, and then we can scale our data. Actually, first, we're still encoding actually. Let's encode. So encode, we'll call it label encoder. Is going to be a label encoder object from sklearn. And y, which is this banking crisis column. If we take a look at it, it looks like this. We're going to encode it using the encoder label encoder dot fit transform method. It takes in the y, so this will fit the encoder to y, which basically takes each unique value and will convert it into a 0 or a 1, and then transform it and then send it back into y. And I just want to make sure I know which one is going to 1, which one's going to 0, so I'm going to make this new variable y mappings. Well, I don't really have to make it a variable for our purposes. I could, but I'm just going to call it, make it a dictionary. I want to print the result. It's going to map an index to a value for every index. Let's call it label. For every index and label, for every index label pair, and enumerate label encoder dot classes. So this is the attribute that is a list of all the classes that are encoded, crisis, no crisis, but it will be in the order that it encoded it. So if we enumerate that, we can get the mappings. And that, okay, so crisis went to 0, no crisis went to 1. I'm not too happy with that, right? Because now if we look at y, now it's an array of, oh no, I closed that 1 second. It's an array of zeros and ones, but crisis has gone to 0 and no crisis has gone to 1. So I want the positive example to be 1. So how can I fix that easily? Well, very simple. If we convert this back to a series really quickly, then we can just apply a lambda function. I know I could do this if it was a numpy array using the map, but I like the. It would be. We'd have to process. We have to convert the type like 2 more times. So this will take some x, which will be one of these zeros or ones, and just return 1 minus x. Right, makes sense. If 1 minus 1 is 0, 1 minus 0 is 1, so it flips it. So if we looked at that, we'd get the proper encoding, which is crisis goes to 1, no crisis goes to 0. And we can store that in y. Doesn't matter that it's now a series, that's okay. Alright, and I will just paste in the markdown for this. Now y equals 1 means we have a crisis, and y equals 0 means we do not. Alright, now we'll scale. Alright. So I'm going to make a scalar object, which will be the standard scalar from sklearn. And x is going to be, well, we'll just say scalar.fitTransform x. But this returns a numpy array, and I actually want to get a data frame out of it. So we're going to turn it back into a data frame and make sure to keep the columns with the same names as they had before. Alright, we look at x. Now everything has been scaled to have mean 0 and variance 1. And I think we're ready to train. So one last step. Splitting. This is just going to split into train and test sets. So x train, x test, y train, y test equals train test split x y train size 70%. Alright. And we give it a 70% train size, so 30% of the data is going to go to the test set, and 70% will go to the train set. And now we can train. So as I said before, we'll be using TensorFlow. So we'll create our input layer. This will just be a basic model, basic two hidden layer neural network. So tf.carrots.input, and we have to specify the shape of our feature vector here, and it will be of size 23. You can see right there. Alright, then our first hidden layer will be tf.keras.layers.dense, so fully connected or dense layer. 64 activations, and we'll give it an activation function of ReLU, and we'll pass in inputs. And I'm just going to have a copy of that, except here I'll pass in x. So 2 of the same, and then the output layer, which will be tf.keras.layers.dense, but we'll only output 1 here with an activation of sigmoid. And even though there are 2 classes, we're only outputting 1 value, which will be the probability estimate for the positive class. Alright, and then our model will be tf.keras.model, and we'll specify the inputs from above and the same with the outputs. Alright, we can compile our model. Whoops. We can use the Atom optimizer And for our loss, we'll use binary cross entropy. And for our metrics, that's actually a good thing to check. First, let's just take a look at the shape of X, and also we want to check if our classes are skewed. So remember, Y looks like this. If we sum across it, that will just sum up all the ones, and we'll get the total number of ones. If we divide that total number of ones by the length of Y, or the total number of examples, we'll get the percentage of positive examples in the data. And it's 0.8%, so this is almost like anomaly detection. Very low. So we can't use accuracy here, right? Because if we guess no crisis 100% of the time, we'd get a 9.2, no, 92%. This isn't 0.8%. This is 8.9%. Right, but we get a 91% accuracy if we classified false at every example. So we'll use a different metric, which will be the area under the ROC curve. So tf.keras.metrics.auc. By default, the curve we're using is ROC, and we'll give it a name, AUC. Okay. Then we'll declare the batch size, make it 64. Number of epochs we'll train for 60. And then model.fit, let's store that in a history object. And xtrain, so we're going to train it on the training set, xtrain ytrain. Give it a validation split of 20%. We will specify the batch size as above. Specify the epochs as above. And let's give it a callback function. This one, reduce learning rate on plateau, will help it converge. And then we'll just turn off verbose mode to keep our notebook clean. Alright, while that's training, I probably didn't pass something in here. Yeah, X should go. Okay. Alright, now we can, we're going to visualize it. That's already done. Look at that. So, I guess we could call this results. So we can use plotly express to make a very quick and dirty graph. So fig will be our figure, and px for plotly express. Dot line will be a line graph. We'll be plotting the history.history attribute. So this history object has a .history, which contains two elements, loss and val loss. Then our labels will be a dictionary that maps the index to the epoch and the value to the loss. Alright, and our title will be training and validation loss. Alright, let's do fig.show. And it looks like this. So it looks like it converged very nicely. And I was experimenting with the epochs earlier on this, and this looks like the optimal number of epochs to train for. So let's go ahead and evaluate our model, see how it did. And we're going to evaluate on the test set here. And we got an area under the curve of 0.98, and that is exceptional. That is very good. We were both able to classify the positive examples well, and we were able to classify the negative examples well across all classification thresholds. So that is very good model performance, and I'm guessing we did so well because there's already very strong predictors of a banking crisis in here, like systemic crisis, currency crises, inflation crises, etc. So I guess that sums it up for today. I hope you liked the video. If you did, make sure to subscribe and hit the bell, and leave any comments in the section below. I'll see you guys tomorrow. Have a fantastic day.